Hello folks, we've got one of the more unusual sets today. Although I'm wanting to do a communicators NI440DX or a set that uses that chassis to demonstrate the adapter plate that one of our viewers and another dealer has made to turn those into an Amstrad type of power lead, which we can make. I've just thought I'd do this because, well, I'll have a go at doing this. It's a Jesan KT5005, I said 5100, and it comes with the white mic. It's aimed at the marine market, it's a CB for the marine market, and it also has two marine band channels. Now, strictly speaking, you can't combine other radio equipment within a UK 2781 CB radio. It has does it have a separate socket for it? It does on the Ladyline one. So this is why you didn't have any kiddies walkie-talkies with built-in medium wave transistor entertainment radios, because you can't combine the equipment. So strictly speaking, this is a bit of a grey area, but it really doesn't matter. And they were supposed to be totally illegal, but I can see a grey area. So I think we've got probably going to have a duff capacitor situation. I've got no information on those. We've had one before. I can see self-tapper screws coming out, which I don't like. Because basically, oh sorry, no, the Ladyline one is the Uniden based one, so I can't even remember what's in here. It's years since I've seen two others. The one I own and the one my friend Mark, G7NDJ, owns. Right, let's see if there's enough heat in the smouldering vat. So straight away we can see the little subboard for the marine receive channels. Remember, it's receive only. I'm trying to think what it even is, if we've ever seen one before. You know, in this chassis as something else. It certainly wasn't in the first years. This would be the later 80s. I think we'll do it without the lid on. So just see what he says in his notes. He sent a letter with it. Please find this was on eBay purchased several years ago. Rigs always had poor receive audio. Reason for to fill with LED display, which dims when the squelch cut with the yes. He replaced the 10.24 crystals. One of the legs has snapped off. Started replacing some. I did two electrolytics. I damaged the track, which I've rectified with the longer green wire underneath. The meter lamp was replaced by me several times with that white LED. Well, we won't mention anything there. Danita Mark 5. Yeah, well, we're not buying CPT only sets, but when they turn out, we've got the Mark 3. Yeah, have we not covered that? We've got the Mark 3. Yeah, the Danita Mark 5. The ones which you have UK channels, they're fake. I think it was Palmer were the importers, and they were modifying them without a license to do so. So they're fake. Right. I've noticed Palmer aren't in business these days. So we've got the mic with it's got one of the screws missing. So that's going to have to be dealt with, otherwise the plug's going to, all the wiring's going to come out. Well, it's standard Uniden connector, but it isn't a Uniden set. And we'll plug it into our extension speaker, but we'll start with it in PA. Yeah, right. Oh. God, it's like a headlight on that. PA. Testing 1 2, testing 1 2, 1 2 1 2. Well, that works great. Right, back to CB. When you turn the squelch, oh my goodness, it does, doesn't it? Let's put the extension speaker in. Oh, it sounds not normal. How bizarre is that? So difficulties without a circuit diagram. What does one do? It's not like these have a dimmer. Right, well, I'm going to pause the video and I'm just going to look whether he's got this green wire right. That's going to introduce capacitance, and it might be better for us to actually put a fine link in, which Mr. Chippy would be best at. Okay, so the top and bottom with this set is it's been messed with. I think he bought it on eBay a few years ago, and the squelch control's physically being linked into the display, so it's kind of ridiculous. When I did the last one of these, and I don't know where, it would be really easy if I knew where our own one is. It's in storage somewhere. We've had a lot of building work between 2020 and now. Had the chapel built, and we've had the organ installed. So I'm not quite sure where that is. It could be here, it could be elsewhere in storage. 2020 is when we did it. I mean, that's only 4 years ago. But I don't know where it is, and if I could just copy the wiring, it'd be so easy. So I did a search for the KT5005, and in fact, David put me onto this, who often comments on here, quotages. Somebody who's got some circuit diagrams, and it's one which wasn't there a few years ago and is now, so that's an improvement. So we've got a circuit and we should be able to get things sorted, but you never know. Is this yellow wire supposed to be there? I don't think that's very good. That green wire is supposed to be there, and that's the green wire which I've improved from where the customer's actually damaged the print. So we're not going to have a capacitive effect with it going all the way down there, hopefully. So if we look at where the squelch controller on this, we can see that one end and the wiper go to earth, to chassis. And we have indeed got we've got one end in the... I've just disconnected that. So where does that white wire go? This could be the where it actually goes to the radio. It'd help if there wasn't a subboard in the way. I think it's there. So on the circuit, well, it goes to a preset, of course it does, for the preset squelch, which looks to be, looks like 3V3 is the preset number, and diode 8. All this space is where it would be an AM FM set. So RV3 is definitely there, and diode 8 is definitely there. So we can see on the circuit, I've lost it already, diode 8 and preset 3. So one end of this should end up going there. I'm just going to pop this subboard out so we can actually see what's going on. It looks to be that white wire, that white wire. So if it's that white wire, it's 0.23, and 0.23 is there. So the question is, does it go where we want it to go? Well, you know what? I don't think it goes to Earth. I think that's the crux of the matter, is it doesn't go to Earth. So what's happened to the... Are these two linked together as they're supposed to be? And the answer is, they don't appear to be. So has the squelch preset been changed and they've cocked up the wiring, or what? Well, as far as I'm concerned, all we need to do is to link the two pins of the squelch control to chassis. The squelch should then work normally, and the display shouldn't work at all because I've disconnected the wires. Right, so I've definitely got both of them connected together as the circuit diagram shows. Just make sure that board isn't going to short out anywhere, and we'll switch the thing on. So obviously there's no display, but the squelch should work. Good. I'll put a signal higher on and it works. Good. So that's the squelch working, no display. So now we need to find out where the display gets power from. So we've got two wires, neither of which I think should be going to the squelch control. It is possible that the black one is earth and it does pick up it's earth from there, but I won't be that sure. So according to the circuit diagram, pin 9 of the LC7137, you've got a resistor 79, and the far side of that is what goes to the channel selector switch. So on pin 9, if you just move the crystal to one side, on pin 9, it's a 10-pin chip, isn't it? This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's pin 9. So if we turn the set over, I've lost my bearings already. 2, 3, 4, 5, 6, 7, 8, 9. So pin 9 is there. That looks like it should be a resistor 79 that isn't fitted. You see, there you are. What do you do? In its place, we've got another resistor. The far end goes to there. And the purple wire so you know the circuit diagram's not right because the set's altered. So that's where I was thinking we were picking our power for the display. Conversely, one end of the display goes straight over to the marine band switch. So where does the green wire go? That goes to the radio main board. And where does the blue wire go? To the radio's main board. So I would suspect that this black wire, which I've removed from, shall I call it the far side of the squelch control, actually picks up the display's ground from the squelch control's ground. So I think it should go there, but it was previously or shall I say previously the two pins weren't linked together. So I think that's right, but the power pickup is this brown wire. So now when we switch on, we still shouldn't have a display. That's correct. So the brown wire should be picking up its display from the centre pin of the marine band switch. And you know what? It would be long enough to do that. Right, but just for now, we're still not sure where that goes. Just for now, I'm just earthing it to make it work. So, we've got Marine Band 1, we've got Marine Band 2, and Marine Channel 1 and 2, and nothing affects the display. So, I wonder if it's supposed to go out when it's in Marine Band 1 or Marine Band 2. So that's something to think about. But I'd rather spend some time in getting the set working and proving. We're not out of the woods yet. Was it being off frequency this far? Right, I'll put picture in picture on, and then we can all see. Get the sheet for the set. So first of all, we'll do what we usually do. We'll look at the power, and on channel 20. We have got bang on 4 watts. On channel 40 we've got 3.5 watts. On channel 1 we've got 4.2 watts. On channel 20, these don't have low power. We're drawing 1.18 amps. Deviation, while it says 1.8 on here, but it may be lying. And here comes the biggie. Here comes the snag. So let's go over to the frequency counter. Dirty control. Right, going to transmit, we should be 27,79125. We're 27,78929. So it's very, very off frequency. It's illegally off frequency. So this is where his receiver's going to be a problem. It's not going to be the receiver's a problem. It's going to be that it's so off frequency. So can we get it anywhere near? You know what? We can. Well done. So now it sounds off frequency because I've set the signal generator deliberately off frequency to be able to do the test. What was it? 78924, I think it was. Still like it to be a little bit higher. Very fine adjustment on this set. There we go. And we'll see what the Synad meter says. So I'll just plug that in so that the speaker we can hear. Right, here we go. Synad meter. So for 12 dB, at the moment we have got, actually it's really good one, it's 0.48. Wow. I don't think this sets off tune at all, apart from the frequency. A little bit on the transmitter to get it a bit more. That's 1.5. I'd like it a bit more equal between channel 1 and channel 40. Squelch. Full squelch is far too tight. It's 10 millivolts. And the threshold surprisingly, it's not good enough, it's 2.2, but surprisingly with that kind of figure that it works as well as that. So that is too great, it would be chopping around scratchy corner. Right, I'll check the alignment of that as a freebie. There would be a fee for that. I'm just telling everybody because it's another setup procedure. But I'll just try and get this chappy out of the proverbial. Right, let's go to transmit. I'll take a break then. Need that cup of coffee. Right, transmit, here we go. So not sure whether that's transmit. so I'm not going to move it much. Well, we've got a circuit, haven't we, now, so we know what's what. So L4. Yep. L4. T10. Yeah. T10. It's a matter of seeing them. T9 and T8. 10, 9. It is. It's that is on transmit. That's spot on. That's having little effect. Down to careful placement of these again. Or watts. So go to channel 1. It's 4 watts. Go to channel 40. It's 3.7. Not ideal. Just see whether this one will bring us up at all. Yes, it will. Still 3.7. I think that's got a dry joint on it. It's intermittent. Turn the power off. I think we need to unsolder it. I think there's a board crack. I wouldn't be far wrong there, would I? There is. That's why it's intermittent. So it's hanging on by the skin of its teeth. What we'll do, we'll add a chopped off component lead to cover the fact there's the print crack. You don't want any spikes on the RF outputs, but in a physical spikes, soldering spikes, wiring spikes, it needs to be smooth. And that's a dry joint. Yes, look, I'll recheck this. Right, so that's channel 40, that's channel 1, and that's channel 20. You're going to be now astounded. Yes, Mr. Tango. That's brought our current consumption to 1.23. So we'll find the RF meter. Chances are it's going to be that one. It's dirty. Waggle that around a bit. Try again. Centre of the red zone. So we can't do high load power. L10 wasn't it? L4. So that's his intermittent transmit rectified. Good. So deviation, we'll just go over to the test set. First of all, we'll see where it is. I think it's going to be that one. Oh. Wallow. That looks to be the one. Wallow. It's spot on now. So it was spot on before. I did just touch it, but it's still more or less where it was before. .2 to 2.4 kilohertz is what I spotted. There we go. So we're just... So if all else fails, we'll be putting that to ground, this display wire, because it differs from what the circuit diagram says. Just before I do go for a break, I want to do a detector, and I can switch the oscilloscope off. .100 microvolts onto the oscilloscope. Yeah, I paid the electricity bill yesterday. Just. Right, a detector. It's probably that one. But on second thoughts, it's this one, isn't it? Because that's where the FM chip is. Out. That wouldn't have helped with his audio either. That will have altered the receive sensitivity. I'll tell you what, I will just go through this and then I'll just not set the meter in that. Let's go over to the Synad meter. Got the attenuator on, so we're about 4 dB. Spot on. That was spot on. Very, very tiny adjustment there. Put a bigger signal on for these intermediate frequencies. Let's get a look at a new figure. So now the detector, right, is it worse or is it better? Well, we've got 0.4 0.46, 10 dBs, 0.33, and it'll still do 20. So it's 1.3. We turn it to 12. There we are. So we have improved received, and I'll now put the speaker in that we can actually hear. Right, I've done a photograph, so we'll fill this in later, so at least I'll have that for reference in the future. But it won't solve the wiring thing. There's been some alteration. Right, let's do the receive. Oh no, I've done the receive. Let's do the S meter. So right now it's plus 30. I would think the preset there is going to be the S meter. Which one of my crocodile clips is coming off? So I've got my eye on the clock. We're on a road trip to Sheffield shortly. Oh no, it's not that one. Is that the squelch? I think that was the squelch, wasn't it? So it must be that one. Yeah. Another dirty one. I think they're all dirty. There we are, that's S9 set. Need to clean the volume control. And this is the type which is easy to clean. So we'll do the squelch now. So squelch to full. I've got 100 microvolts on the signal generator, and we'll adjust the preset till that comes in. That's now spot on. And hopefully that's improved the sensitivity end. Turn the squelch down, set threshold. I wouldn't say it's that brilliant. 1.4 is the first reading. Try again. Set threshold again. One. Right, we'll look at these marine channels. So what have we got? Marine band 1. So I said this would be at extra cost, but I'm not going to do that because it makes an interesting video. So it says here the marine band 1 is 48.70166. So with the pink calculator, well, Big Clive's got a pink calculator, so I need a pink calculator. 48.70166. 48.70166 will be times 3 plus 10.695 or 7. That will bring us to 156.8. And the other one says 48.58 by the looks of it. 48.58 times 3 plus, that didn't work, did it? 48.58 times 3 plus 10.7 is 252.75. That's, what have I got there? That's not possible. 48 point, is it 5.6 or is it 5.8? It could be 5.6. 0.56 times 3 plus 10.7, 156.38. That doesn't sound right. Let's try it with the 8 instead then. So 1. No, it's not. It's not. It's 48.58 times 3 plus 10.7. 156.45. I'll just see if they make any sense. I'll go and look up some marine channels. Okay, so I've looked up the marine frequencies. It looks like the first channel is 16 and the second channel is 9. So if we put 10.695 into these frequencies rather than 10.7, which would be the correct IF, we should be spot on. So let's try again. 48.70166. 48.70166 times 3 plus 10.695 brings us to 156.79999. So 78. So it's definitely 10.695 IF. I was putting 10.7 in as a guess, but of course the set wouldn't have a different IF. So we need to set this. No, we don't. This will be on. So the way to do this, we'll have that on. We need to have the signal generator set to the first marine channel. So we'll put the frequency counter on the inset picture. And we'll now have to change this major, because we do VHF. We use this test bench solely for CB, and all the other test benches we use for VHF and UHF business radios. So really I should go over to another bench, but we're here and there's no cameras on the other benches. So we need to take this right up to 150 odd. Alright, 156.8. Right, here goes. Does it work? Wow. It does, it's as deaf as a post. Turn the tone off. So we've got a high-pitched musical noise, which we need to nullify. Quicker to put this in the right socket. So hopefully you can hear that. To bring it on frequency, we need to adjust the appropriate trimmer. And I don't know which is channel A and channel B. You know what? I didn't think it was going to go on frequency there. Wow. So we'll turn the signal generator. No, we'll do the other channel. So 156.45. Switch channels on the radio. This channel doesn't appear to be working. I've just double checked we've got the frequency right. Don't know whether the crystal says anything on it. .58.56 48.56 48.56 times 3 plus 10.695 equals, it's 156375 when we actually get to it. 156375. If I flick my pen on the floor, it is receiving, I can hear it. And that's the importance of getting the frequency off the crystal and multiplied and the IF offset all correct. There we go. So we'll take the tone off. And that goes on frequency too. Brilliant. So I'll make a note of that before I forget. I think I flipped my pen somewhere on the floor. That'll never be seen again. Now this is deaf as a post. And when I say deaf, I mean deaf. So we're looking at 100 microvolts. Get the cyanide meter back in. That's it. We're not going to get better than that. So it's like 100 microvolts. So it's as deaf as a post. It could be faulty. I'm not going to go into it, but it would pick up an S9 type of signal. So if you're by a marina, yes, it would pick up, but it's as deaf as a post. And I haven't got another one to go by as to what the sensitivity is supposed to be. It's just there as a bonus joke, isn't it? But it is on frequency now, so there we go. So we're all done. So I think we'll tag this to ground. Just so we can finish the set off. Oh, hang on folks, there's a wire off. I'll bring the sensitivity up. So as soon as I put that on, we should have a much better sensitivity. You know what? I'm going to put a rigid pin through there. Quite a thick one. So that the connection's made on the top. To be more satisfactory. That's better. Yeah, it's still looking about S9, but it's at least it's working as they've intended it to. You've got to be careful with that wire. It's pretty thin stuff. Right, there we go. So we'll put that on an earth. Because we don't know quite where it goes, I'm going to put it to a coil can. So it's obvious in the wrong place, if you can understand that. Right, I'll find my colouring pens and we'll get it coloured in. Right, we've just got in from the Sheffield road trip, so it's time to put this back together. I did hear it chuntering to itself on 19. Just check the continuity of this speaker. It's been written on which way round it goes, but that doesn't mean it was right in the first place. So, does black go to chassis? It does. Does brown go to chassis? It doesn't, so that's a good start. Which means, I hate to shorten these wires, but They're so knackered looking. Let's take the knot out of that one. So I'd have liked to have been able to compare, because I've just earthed the brown wire to make the display come on, and I don't know whether it's supposed to go out when it's in marine mode or not. And unfortunately, the display is what differs on the circuit diagram to what we've got here, and that's just typical. It's the old "we continue to strive to improve our products" business. So we've been to Sheffield. I was going to take a camcorder. Couldn't find the 4K camcorder, so took along the one which we do the on the air test with in here. And so I'll start filming at this point. Was there a memory card in it? No, there wasn't, so that was the end of that idea. I've gone and put it on the wrong one now. I really don't want to shorten this one. I need to do this microphone. Let's see if we've got I'm going to say a scrap microphone plug. They're not scrap at all. It's just that the new ones that get cut off new plugs, sometimes we can only get mics with plugs on them, and then they turn out to be the wrong plug. So we can cut the plugs off them and use them for spares. I do have these teeny weeny screws. These teeny weeny screws and the other teeny weeny screws, they come from Knights at Curtin in Lindsay. So hopefully this second-hand screw fits. One Anna Roger. Put it on its own speaker.
He said he didn't like audio lines, he only wants a unidam.
Right, well, we'll see how it works on the air test. Away from the swearers. So there we have it, the quite unusual Jesan KT5003. I think they were around a bit later, these. I think they were around about 1986. That kind of era. So hope you found that interesting.